Hello and welcome to this recording in which we will look at how we can use regression and correlation for forecasting. Regression analysis is a means of developing a linear model. Regression analysis finds the line of best fit computationally rather than by estimating the line on a scatter diagram. Y will be the dependent variable and X will be the independent variable. Once we're given a value for X, a forecast for Y can be obtained. It is a much more statistically valid method of establishing a trend than the line of best fit or high-low analysis. Within the formulae for a straight line, y equals a plus bx, the values of a and b are specific to the particular relationship being examined. Once identified, they remain constant, and it's assumed that there is a linear relationship between a and b. Hence, we have the formulae y equals a plus bx. In order to calculate the values of a and b, we need to use these formulas. So we're going to look at an example of how we can calculate the values of a and b and how we can then use this information for forecasting. So a company has the following data on its sales. It's during the last year in each of its regions, and it's also told us the corresponding number of salespersons employed during this time. We're required to develop a linear model for forecasting the sales from the number of salespersons. We will then use that model to forecast what the sales would be with 16 salespersons, and then we can also test the validity of the model by forecasting the sales at 18 salespersons. So firstly, it says develop a linear model. Well, regression analysis is a means of developing a linear model. So we're going to carry out regression analysis. So what we are aiming to do is work out the formulae y equals a plus bx, where we need a value for a and a value for b. Now looking at these formulas up here for the calculation of the value of a and b, it incorporates x and y. So x will be the independent variable and y will be the dependent variable. So within our information that we've been given in this example, we know that we're using salespersons and sales. So we're using sales and salespersons. So one of these will be x, the independent variable, the other will be y, the dependent variable. So we need to decide, does the amount of sales depend on the amount of salespeople that we have, or is it the other way around? Does the amount of salespeople depend upon the amount of sales we make? Well, fairly obviously, our sales is going to be influenced by the number of sales staff that we have. So our sales will depend on our salespersons or salespeople. So sales will depend on salespersons. So y is the dependent. So our sales will be y. Salespersons are independent, so that will be x. So now that we know the values of y and x, we can begin to work out the figures that we need to go into our formulae. And we can look at this on the next page. So here we have our values of X. So this is our salespersons. Here we have the values of Y. This is our sales. The next thing that we need to work out is X squared. So that is 11 squared, giving us 121, 12 squared, 144, and so on. So it's the value of X squared. And we need to work out X times Y. So 11 times 236 gives us 2596. 12 times 234 gives us 2808, and so on. We then total these four columns. So we've got total of X, Y, X squared, and XY. And the symbol for a total, sigma, which is used in the equation. So we now have all the information that we need to work out values of A and B. So the formula for B, it is equal to N. Now, N is the number of sets of data that we have. So we have 1, 2, 3, 4, 5, 6 sets of data. So N is equal to 6. So looking at our formulae, its value of B is equal to N, which is 6, times sigma, which means total of XY. So the total of XY is 19736, minus sigma X, which is the total of the X column, times sigma Y, which is the total of the Y column. That is all divided by N times sigma X squared, total of the X squared column, minus sigma X, so the total of the X column, which we then need to square. And if we work this out, we will get the value of B. So B equals 10.12. When you're working this out, try not to do the whole calculation in your calculator in one go. It's worth doing it in stages to guarantee that you get the correct answer. Now we can look at the formulae for A. A is equal to sigma Y, so that's the total of the Y column, divided by N, that we know is 6, minus the value of B, so 10.12, times sigma X, so that's the total of the X column, which is 79, divided by N, which is 6. And when we work that out, A is equal to 111.09. So our formulae, Y is equal to A plus BX. And there we have our linear model. So let's now look at what the next requirement was. So we've developed the linear model. So forecast what sales will be with 16 salespersons. Well, we know that X represents the salespersons. So into our linear model, for the value of X, we will put 16. So Y is equal to 111.09 plus 10.12 times 16. And that equals to the nearest whole number 273. So we can forecast that our sales will be 273 units if we have 16 salespersons. Part C asks asks us that using 18 salespersons test the validity of the model. So into our formulae, Y is equal to 111.09 plus 10.12 times 18. This tells us that with 18 salespersons we should sell 293 units. Now if we look at the data that we were given, we actually had a figure for 18 salespersons, 298. So this tells us that the model is not completely accurate. With 18 salespersons, we've got 298 units of sale. Although, according to our model, with 18 salespersons, we would make 293. So there is a degree of inaccuracy. A reason for this inaccuracy could be that we've based this model based purely on 6 pieces of data. That really is insufficient data to use to produce a valid model to use for forecasting. Ideally, we'd want at least 20 pieces of data. We can also use Y equals A plus BX to forecast total costs. When we use it to forecast total costs, A will represent the fixed cost and B will represent the variable cost. So the model can be used for identifying fixed and variable costs as an alternative method to the high-low method. So we've seen that there was some inaccuracy in our model. What we can also calculate is the correlation coefficient. This will tell us how strong the relationship is between the two variables in our regression model. To calculate the correlation coefficient, which is referred to as R, we have another formulae. So we have n sigma xy minus sigma x sigma y divided by the square root of n sigma x squared minus sigma x squared, and this is all multiplied by n sigma y squared minus sigma y squared. As before, n is the number of sets of data that we have. The value of r will always be between -1 and +1. If it comes to exactly +1, it denotes a perfect linear correlation between the two variables, which is positive. If it comes to -1, it denotes a perfect linear correlation between the two variables, which is negative. On a graph, perfect positive correlation would look like that. So r would be +1 and this would be r equal to -1. So we've got a negative correlation and a positive correlation. If r is 0, then there is no relationship between the two variables. So what we're seeing in r is how strong the relationship is, and that in turn can confirm the accuracy of your model. We can also calculate the coefficient of determination. The coefficient of determination is your value of r squared. And what this shows you is the percentage change in the dependent variable that can be explained by a change in the independent variable. So these are useful methods of forecasting. However, what we do need to bear in mind is in particular the sample size. So we'll now look at an example of calculating a value for r and for r squared. So here we have a company that is investigating the effects of its advertising on sales. So our sales will depend upon the advertising. So sales is the dependent variable, which is y, and advertising will be our independent variable, which is x. We need to calculate the correlation coefficient, which is r, and state what it means, and then we need to calculate the coefficient of determination, which is r squared. So we need r and we need r squared, and state what this means. So if we draw up a table, we have our values of x, which is the advertising. We have the values of y, which is the sales. We need to know the value of x squared, because x squared appears in the correlation calculation. Similarly, we need to know the value of y squared, and we need to know the value of x, y, so x times y. So you'll see that much of this is the same as we use for the regression analysis. We've just got one extra column, y squared. So just a reminder, x squared is the x value squared, so 1.3 squared. Y squared is the y value squared, so 151.6 squared, and then xy is the value of x times the value of y. So the first figure is 1.3 times 151.6 gives us xy. We then total all of those columns, So total of x, or sigma x, sigma y, sigma x squared, sigma y squared, and sigma xy. Remember, sigma meaning total. We can now slot those into our correlation calculation. So correlation coefficient R is equal to n sigma xy minus sigma x sigma y divided by the square root n sigma x squared minus sigma x squared times n sigma y squared minus sigma y squared. So n represents the number of sets of data. We've got 1, 2, 3, 4, 5. So n is 5. So R is equal to 5 times sigma xy. So go to the xy column. Sigma means total. 1366 minus sigma x times sigma y, which is 7.6 times 842.2. Divide that by the square root of n, which is 5. Sigma x squared, go to the x squared column, that's 12.4. Minus sigma x, which is 7.6 squared. And then that is multiplied by n, which we know is 5. Sigma y squared, 150,553 minus sigma y squared, 842.2 squared. And then the whole of that is square rooted. So again, as I said earlier, work this out stage by stage. Don't try and put the whole calculation into your calculator in one go. And the answer to this is that R is equal to 0.99. So this indicates that there is a very strong positive linear correlation between x and y. R squared, which is the coefficient of determination, is 0.99 squared, which comes to 0.98, or it can be expressed as a percentage, 98%. So that tells us that 98% of our changes in our sales are due to changes in the advertising. The other 2% of changes in sales are caused by other factors. So that is as we would expect, given that R calculated to 0.99, indicating a very strong relationship between advertising and sales. So we would expect that the changes in our sales are, on the whole, due to the changes in the advertising. So that is your calculations for regression, correlation, and the coefficient of determination. And that brings us to the end of this recording.